Okay, this is section 4.4, question P35, and we have two treatments and a placebo. Notice that they are calling the placebo a treatment, even though you could also consider it a control. That's really tomato, not a big deal there. But do be aware that sometimes that is done in research. So we have an experiment, and we're given this drug and then checking the number of eyelid flicks per minute. So sometimes the challenge in these experiments or studies is figuring out, you're interested in drowsiness, but how do you measure something like that? And especially, how do you measure something that's observable? Using our technology or maybe even without technology. So eyelid flicks is something that's reasonable to measure, and certainly it would have a high correlation with drowsiness, although there could be other causes of that. And notice that we have this randomized block design so that within patient 1's going to have a certain baseline number of flicks per minute, and here we might guess that that's around 33 because that's what happened with the placebo. And then we have what patient 1 does on treatment A and C. So because we have all three measured on patient 1, it takes out the variability due with maybe patient 1 is a caffeine addict, or maybe patient 1 has a little kid and doesn't get much sleep in general, or there could be all these things about patient 1, but by giving patient 1 all three, we can take out that variability related to patient 1 or patient 2 or patient 3. So it's a lot of advantages to that design. And the question here, first question says, do the parallel dots show much evidence that one drug is performing better? So we have them all on a common scale where our horizontal axis is this outcome of eyelid flicks per minute. And then we have these three treatments. So you can see each dot represents a treatment. For example, patient 1 on treatment A had 31.25. So 31.25 right there. That's patient A patient 1 on treatment A. So each dot represents a patient on a particular treatment. Notice that our unit here is patient on treatment. So we have 27 units instead of just 9 from the individual patient, because each patient is on each treatment at separate times. So yeah, looking at these, it doesn't seem that anyone is necessarily better than another. It does maybe look like A and C are both a little lower than treatment B, which is no treatment. Treatment B is the placebo. And that's a good thing in this case, because lower eyelid flicks per minute means that we are drowsier, according to the intro paragraph. So it looks like both A and C may potentially be working. And then we look at this scatter plot here. Now this is, it's a tricky scatter plot to read, or it's very potentially misleading, especially if you've done a lot with correlations and regression line, because you see this, and even I did, when I saw these scatter plot points, and then you see this line going through, you just assume that it's the regression line, but it's not. I mean, obviously, we could get a better fitting line if we moved it up a little bit, maybe rotated it a little bit. Right now, the only one below is there, and we should have all the ones above and below balancing each other out to get, if we're dealing with a line of best fit. So it's not a line of best fit. It says it's the line y equals x. So why is that line even on there? Well, let's take a look at what we're being asked. Does it now look as if treatment A is better than treatment C? Well, how would we know? We see that treatment C is on the x-axis and treatment A is on the y-axis. So the first thing we might want to do is figure out what is a given dot here. So a given dot, it says average number of eyelid flicks per minute for a subject. So this is a subject that took A and C, like all the 9 subjects did. and we see that they had about 25 on treatment C, 28 something on treatment A. So that would be, what did we say? 24 something on treatment C, 28 something on treatment A. So probably this patient number 5, I think, is what we're looking at there. So this dot right here represents patient number 5, and we know the number of eyelid flicks when patient number 5 took treatment C, and then when patient 5 took treatment A. So each of these is an individual patient. So how can we tell if treatment A is better than C? Well, here's where this line y equals x comes in. If treatment A and treatment C were exactly the same, and we didn't have much other variation, we would expect if a patient got a 27 on treatment C, they would also probably have 27 on treatment A. In other words, we would have a dot right there on the line. If they had a 31 flicks per minute on treatment C, then they'd have about 31 on treatment A, like that patient actually did. So this would be a good representative patient if the treatment A and C were exactly the same. Now we might also have a couple below the line and then a couple above the line by about the same amount. So it really would look like a line of best fit, even though it's not. This is a separate thing here. But y equals x is when these two, any value on the x-axis is the same as the value on the y-axis. So the effect of treatment C is the same as treatment A. So for this patient right here and this patient right here, we would say that yes, they were about equally effective. For this patient, which one was more effective? Well, this patient had little under, let's say, 29 or 30 for treatment C and 28 something for treatment A. So we would think that it's lower for treatment A, and not think, it is indeed lower. We can tell because it's below that line. So the treatment A for this patient is more effective than the treatment C. For all these other patients, well, these other 6, their treatment C is lower than their treatment A. In other words, lower amount of eyelid flicks, in other words, drowsier. They were drowsier with treatment C than they were with treatment A. So we would say that treatment C is probably better than treatment A. Oh, stop. Sorry. So obviously this answer doesn't agree with what I was saying. I was saying treatment C is better than treatment A. I was assuming that we wanted the medicine to help us sleep, so I assumed that we wanted to be drowsy. So when we're looking at these dots here, treatment A does indeed have a higher amount of eyelid flicks per minute than treatment C, but that's actually a good thing because these medicines are for, we do not want drowsiness, so my apologies on that. So in the case that we want an antihistamine without drowsiness, then we do want people to remain more alert, so we do want those higher amounts of eye flickers, which in 6 of the cases was treatment A, and in only 1 case was treatment C, and 2 was roughly equal.